Okay. When we have the next class, I like to kind of just go back through a review. I haven't seen you for a couple of days. You may have took a nap. You may not even read your notes. Okay, so I like to give it like a quick little review. So here we go. We talked about scientific notation. It's a way or a shortcut way to write really big and really small numbers. Now, how do we do that? We do that through the power of 10. Okay, now it's going to have an exponent over here. That exponent can be positive or negative. Positive means it's a big number, 1 or bigger. A negative number means that it's less than the number 1 when it's written out in a standard format. Okay, the next thing is, for it to be done correctly, there can only be one number to the left of the decimal, which is from 1 through 9. 0 does not count. Okay? And we talked about this earlier this week. And then we said, hey, and I'm going to say it again because we have a lab today to do. And in this lab, there is going to be a lot, look at this data chart. There's a lot of numbers. And if you forget to put a unit behind a number, you're going to lose 2 points. And this lab right here, which is easy, is worth 75% of your average. So let's make sure that all your labs, you do the best work you can. So let's don't forget that. The next thing I wanted to say was, hey, I'm not sure if I said this correctly or if I distinguished the importance, but this is a super easy, cheesy quiz test question, and I get students every year who get this part wrong. Let me say this again. In the beginning, there were 7 units, and they were the parent units. I know it sounds silly. These 7 adult parents started to have baby units, okay? Have you ever heard of Sir Isaac Newton? Probably Newton, right? Now, Newton had a unit of force named after him, like 22 newtons. Those newtons were produced because of these adult units had a baby unit, and we called it a newton. And now, how did they do that, Miss Munson? Well, not like the birds and bees. The way that they produced a baby unit was either you are going to multiply and divide those units together. It's called derivatives. They derived, and so through multiplication and division, they had a new unit, which now became for an example, a newton, okay? So these are the 7 parents. I know those are going to be a test quiz question, and students get it wrong, and then they get mad at me. I'm like, it's in our notes. I would go through our notes like crazy. The notes and our unit homeworks are definitely major things that are on our test, okay? Then I said, hey, somebody had a super good question. And sometimes y'all's super good questions, you just don't say them in class, but I will go and say it for y'all. Somebody said, Miss Munson, do we need to fill this part in? And I said, you know what? There actually is more units, but we're going to leave it blank. I just want us to know that these that are highlighted are the ones that we are going to talk about and use in class, but please know that the units get bigger and the units get smaller. But that was a super good question. Now, because of this part right here that we're going to use it so much, you have to memorize it. I don't like to memorize, me either, but I have this acronym that I use. King Henry drinks utterly delicious chocolate milk. Turn the page in your notes. And in your notes, that's the part that we're about to get started. King Henry drinks utterly delicious chocolate milk. Right here. And with that, King stands for kilo, hecto, deca, base unit, deci, centi, and milli. That's how I remember it because it's too much for me to keep in my head. It says over here in our notes that the scientists and the science community decided to agree in the whole wide world that we are all going to use the metric system when we're talking about anything science related. The cool thing about the metric system is that it uses a base of 10, that we are able to use prefixes, kind of like English class, so we can change the value amount. So for an example, kilo is a prefix that goes in front of one of these base units, like a kilometer, kilometers, kilograms, kiloliters, okay? Makes sense. Centimeters, centimeter, right? Centigrams, centiliters. Makes a lot of sense now. And so when we put one of these prefixes in front of a base unit, we can change the value for it to be big or for it to be small. For an example, scrolling down, King Henry drinks utterly delicious chocolate milk. This side is going to be my large side, and this side is going to be my small side. In using the metric system, the cool thing about it is that we're able to do conversions super easy. Now, your teachers in the past probably told you, oh, multiply by 1,000 or divide by 100, which is true. But I don't like to do extra math. So what I'm going to do is I'm going to move my decimal place. So let's practice this. If I'm going to convert from millimeters to meters, where's my milli? Right here. Where's my meter? Oh, look, that's a base unit without a prefix. This right here is the prefix. This right here is the base unit, and this is the prefix. This is the base unit without a prefix. That's what I'm going to do. So I'm going to go from milli to my base unit. Which direction do I need to go so I can get there? If I'm starting here, I need to move to the left. How many places? Let's count it out. 1, 2, 3. Where's your decimal? If it's invisible, draw it in. But it's not. It's right here. Let's move it over. 1, 2, 3. Draw in your new decimal. Add these blank bubbles into zeros. And my new number is 0.005326. Is that not an easy way to do math? That's pretty easy. Let's do it again. Okay, this situation, we are going to go from kilograms to grams. Do you see that the kilo is the prefix and the grams is the base unit? So that means I'm going to start here, starting, and I'm going to end here. Which direction? To the right. How many places to the right? 1, 2, 3. Where's my decimal? Right here. Move it to the right. 1, 2, 3. My new number is 53, or you can type or write 53.0. It's up to you. Let's do it again. We're not done. We got another one. And so for this one over here, it says go from centimeters to millimeters. Well, centi is right here and milli is right here. How many places and what direction? To the what? How many times? 1. Move your decimal over 1. What's my new answer? There you go. Psh. Don't tell me physics is too hard. Not yet. It's pretty easy. And so that's what we're talking about today. Now, I'm going to go ahead and I'm going to stop here. I'm going to put my notes up and I'm going to get the lab out. Okay? So whenever you're ready, let's get that, move it out the way. We're done with the notes for today. We have a lab to work on. Okay. And this is 9:30 class. Okay, here's our lab. Please put your name on the lab. I'm going to write 9:30 because that's how I can distinguish it. And I'm going to put today's date, but you write your name. There's a couple of problems. I found some mistakes I don't like, and so I made some changes. Scratch this part out with your pen or pencil. Scratch this part out and just leave total mass. Scratch the number 1 away. I don't care how many, you might have 8 pieces of foil. Scratch this away and put mass of tape. Okay, I feel better now. Okay, so this lab, This lab is actually called the density of a stellar material. What do I mean? The density of a sun, a moon, a planet, something in outer space. Stellar, okay? Kind of like you probably heard interstellar, right? Stellar, a material. Now we're going to find the density. So hopefully if you don't remember the density equation, I gave it to you. Alrighty, what you're going to do here in this lab is that you're going to go in just a moment, not yet, you're going to get a balloon. With your balloon, you're going to blow it up. How big, Miss Munson? It's up to you. This is my balloon size. You can be smaller. Your star, this is going to be your star. Your star can be bigger. It can be smaller. But this is my balloon. You're going to blow it up. Then after you blow this balloon up, once you put your mouth on it, don't put it back. Nasty. Okay, throw it away. If the balloon has like a hole or something, you know what I mean? Like it's like, oh, this one don't work, or I don't like this color. Don't put it back. All righty? Then imagine how much aluminum foil, take a guess, do you think it's going to take to cover this up? So you're going to go grab, let's say, 3 sheets or 4 sheets of aluminum foil, right? I don't know. You're going to come over here to your table in groups of, y'all can sit 4 people at a table, 3 people, 2 people, I don't care. But you need to sit with somebody to help you out. You need a neighbor to help you. Try it on your own, but if you need your neighbor, they're there to help you, okay? Then you're going to go get some foil that you believe would cover this up. Practice. Try to cover it up. If that's not enough, go get some more foil, okay? But wait a minute. This is not going to be good with just the foil. After you figure out how much foil, you're going to go to the back of the classroom over there by that corner window, and you're going to find the mass and put the unit right here of the foil. Then imagine how much tape. Go get in the back of the room a big piece of tape, like so big, maybe 2 or 3 of these pieces, that's this big, and go take the mass of it. If you need scissors, you definitely grab some scissors, chop up the tape in pieces, and use the tape to help hold the foil, okay? Does that make sense? Then you're gonna get those 2 masses and add it up. But wait a minute, you need more tape. Go ahead, get more tape, and what should you do? Go find the mass, add it here, and add it all together, okay? So in a moment, that's what you're gonna do. Sounds cheesy. You're gonna have a balloon with foil nice and good and tight around it with tape holding it together, okay? Once you do that, you need to, or somebody, a partner in your group, needs to go find the equation for circumference. Do you remember that from geometry? I don't know, what was that, 9th grade, 8th grade? If not, if you have a time right now, you might want to Google search it on your phone, right? You're going to definitely need that equation. You're going to write that equation down right there. And then we are going to come over here and we're going to do line number 1. You're going to do line number 1. After you find the mass of all of the pieces, wait a minute, the mass of the foil and tape is the total mass. What does it not include? It does not include the what? The balloon and the hot air that you use to blow up the balloon. I do not want the mass of the balloon or your air, okay? This mass is the tape and the foil only. You're going to go ahead and get the foil and balloon, and you're going to measure the circumference of it. 4 different locations. Here is your foil balloon. Remember, it's a star. You're going to measure it around this direction, number 1. That's number 1. You're going to measure it around this direction, number 2. You're going to measure it around this direction. Oops, I guess I should have went this way. Number 3. And then you're going to go around this direction, number 4. Does that make sense? That's where you might need your partner to help you. That gets a little tricky. How am I going to measure that, Miss Munson? Guess what? I have pieces of string, or there's a whole thing of string. Go get some string about so big, cut it, go and get a meter stick, and you're going to find the average. At this point, we're all going to stop and come together so we can continue the rest. Does this make sense? And do we have any questions? okay? If we don't have questions, then what we are going to do is my calendar is over here. I have